So this is our final unit in Math 56. It's trigonometry. Some of this you'll have done before, and like always, some of it will probably be new. We're going to start out with Pythagorean Theorem and the sum of angles in a triangle. So all triangles have three sides and three angles. We know from our geometry unit that the sum of the angles in the triangles always adds up to 180 degrees. We're going to do some of our trigonometry on right angle triangles, and that's where we're going to start. So right angle triangles, you can use the Pythagorean theorem and SOHCAHTOA, right? These are the ones that we're going to be solving in the third section. All of a sudden in H.4, we're going to move into non-right angle triangles. And so there is a little bit of a distinction in this trigonometry unit, and it's probably the non-right angle triangles that are going to be new to you. So right angle triangles, as the first part of this unit's about, is any triangle with a 90 degree in it. The sum of the other two angles is also 90 degrees because they've got to add up to 180. So if we want to determine the missing angle here, because this is already 90, you could go 180 minus 90 and minus 30, or you could just go 90 minus 30. In either case, you're going to get to the same answer. Oops, not 36, 30. You're going to get to, I got a 6 on my mind, because it's going to end up 60 degrees. And so the following ones, you're just taking 90 and minusing what you know as the angle that's measured in degrees. Sorry about that. And you can just solve for these. Easy peasy, stuff we've done before because you've done that geometry unit. All right. So now that we've got that down, we can deal a little bit with the sides in a right triangle. Now the sides in the right triangle obey the Pythagorean theorem. We're going to start by labeling a triangle. A lot of our trigonometry is going to work better when we understand and set ourselves up. So it's a little bit different, some the same from our geometry unit. But typically in trigonometry, the angles get uppercase letters. So this would be triangle A, B, C. And the sides across from the angles get the lowercase letter. So the side that's across from C would get lowercase c. The side that is across from A is lowercase a. And the side that is across from B gets to be lowercase b. This allows us to kind of isolate the two different components of the triangles, one being angles and one being sides, because we have different sort of strategies for dealing with these ones. So all this stuff is the same as in our geometry unit, but this convention of labeling the angles with uppercase letters and the sides with the lowercase letters is a convention definitely that you're going to see in trigonometry. So C is usually the hypotenuse. It doesn't have to be C, but the hypotenuse is always going to be across from the 90 degree. There's a thing in triangles, you may have noticed this in the geometry unit, the longest side is always across from the biggest angle, and the shortest side is always across from the smallest angle. So starting out with the hypotenuse and identifying that on these right triangles, we would label each of the following triangles with the hypotenuse. And I'm just going to put HYP for the hypotenuse. For this one, it would be side C would be the hypotenuse. For this one, it's side F is the hypotenuse, just across from that 90 degree. And for this one, it would be side lowercase r would be the hypotenuse. So sometimes it gets spun around, and being flexible in that is useful. So you're looking for that right angle, and the side that's across from it is the hypotenuse. This is useful as we solve for sides. When we know two sides of a right angle triangle, we can solve for the other. So Pythagorean theorem is used to solve for an unknown side when two sides are known in a right angle or a right triangle. So this is Pythagorean theorem. Sometimes folks have learned it in 3 different iterations. We don't really need to have it in 3 different iterations. If we know 2 of these, we can rearrange this equation to solve for the third. It's often standard triangle labeling, but you really could use any letter. So solving for the sides of an unknown or unknown side in algebra, we've learned going to use the skills that we learned, and then one new trick. So because we have a squared here, to get to just C, you'd have to take the square root of the other side. So let's try some of these out. I'm quite sure you're going to remember some of this as we move through it. So starting out in the first one and showing all of my work, I have the Pythagorean Theorem equation. And I can take and sub these in. X is going to be my hypotenuse, right? That's the place of the C. That's what the sum of the other two sides squared is going to equal, the square of the hypotenuse. So if I put in the numbers that I know, I can now do the math to rearrange this. So what I like to do is do this in one fell swoop. So I like doing it all on my calculator, but if you're not ready for that, then you can totally do this in a couple steps. If I want to get rid of the square here, I could take the square root of both sides. So if I take the square root of this side, I get 3 squared plus 4 squared equaling the square root of the other side is just x. That's what we're talking about, is you have to take the square of both sides. So that is a bit of a new trick. We don't have a lot of square roots in this course, so that might be something that's new, but you probably have done Pythagorean theorem before, and so that makes it a little bit easier. This gives me a line that I can put into my calculator. If you're still not ready for that, you can totally do more, especially in this question, of the math out longhand. So we get down to the square root of 25. Well, the square root of 25 is 5, and so x equals 5. Usually, when I do my math, I write it out in this step, and I don't write the remaining ones down here, because if they don't work out nice and neat and easily like this one, it's sort of a lot of extra work. So let's take a look at another one. I always start by labeling my hypotenuse on these ones because that keeps me grounded. My equation is always going to be the same. I'm not going to write that out again, but seeing how this triangle fits that equation, I would have x squared plus 3 squared equaling 7 squared. Like I said, you may have learned this rearranged a number of different ways. Now that we have this, if I want x all by itself, I'm going to have to subtract this stuff from the other side. So I would write it out as x squared equaling 7 squared minus 3 squared. Now you can do this math as you go, or you can remember that you're taking the square root of both sides to get x all by itself, and this gives you something you can put directly into your calculator. So oftentimes that's the way that I show my work. In these ones, we're always going to round our sides to 1 decimal place. And the angles are going to go to the nearest angle in this entire unit. So we'll stay with this one. On my calculator, when I did this, I rounded it to 6.3. I'm going to do one more here, and then I will put my work on the page. So with this one, I like labeling the hypotenuse always to orient myself. Putting it into my Pythagorean theorem equation, I'd get 6.5 squared plus 6.5 squared equaling x squared. On my calculator, the way that I would have this is that the square root of these two things, 6.5 squared and 6.5 squared, is what x is going to equal. And so I can put this into my calculator in one fell swoop. Rounding, I'd get x equaling 9.2. All right, so for the remaining, really, the key is fitting it into the equation properly. So I like labeling my hypotenuse in each one of these. It's not necessary as long as you get it right, but this gives me a stepping stone to make sure that I'm subbing in correctly. I get x squared plus 11.5 squared would equal 13.2 squared. x is going to equal this 13.2 squared minus the 11.5 squared. And remembering to take the square root of it because I want to solve for x, not x squared. So this one, x equals a 6.5 on my calculator. The last ones, again, I'll show you how I would write it out. That one, for whatever reason, I put the x onto this side. It doesn't really matter. You'll get down to the same line. 6.4 is the value of x. And the last one, and using your calculator on this, rounding to 1 decimal. On this one has some tricky rounding. I wrote down on my notes here what the calculator actually says. If we want to round this number to 1 decimal, I would write that x equals 4.0. We have some funny bumping going on where you want to stop the number there, but that 6 is going to bump the 9 up to a 10, which gives me the 4.0. So that's the beginning part of our trigonometry. Let me know if you have any calculator issues in this unit. That is an ongoing concern.